It's astonishingly clear that the geological wonder we know as Yellowstone National Park is not just a picturesque landscape adorned with hot springs and geysers, but the caldera of a potentially cataclysmic supervolcano. This supervolcano is not just a sleeping giant, it's a continent killer, a dormant beast biding its time before an inevitable awakening. My intention here is simply to draw attention to the gravity of what we are observing. We are talking about a colossal 100-foot wide crack that has emerged in the supervolcano under Yellowstone National Park. Scientists have issued stark warnings that this dramatic change has exponentially increased Yellowstone's risk of a sudden eruption by an astounding 320%. When this eruption occurs, it will be a disaster of unprecedented scale. Let's delve deeper into the details. The Norris Geyser Basin and the Steamboat Geyser are both significantly contributing to the elevated risk. But before we dive into the specifics, let's start with some essential facts. We're venturing into the heart of Yellowstone's oldest thermal sanctuary, the Norris Geyser Basin, a region teeming with thermal features that have been active for an astonishing 115,000 years. Here, temperatures soar to an incredible 459 degrees Fahrenheit just 1,000 feet beneath the surface. But there's more. The Steamboat Geyser, a true testament to Yellowstone's dynamic nature, is also a key player. This towering geyser, once an unpredictable marvel with intervals ranging from 4 days to 50 years, has dramatically changed its behavior since March 2018. Now, Steamboat erupts as often as once a week. In 2018, it erupted 32 times, shattering previous records, only to surpass itself with 48 eruptions the following year. This sudden increase in activity raises a crucial question: is this linked to the 320% increase in the risk of a sudden eruption? Let's explore further. The erratic behavior of Steamboat Geyser is just a fragment of the story. Scientists are fascinated by the rhythmic dance of the Norris Geyser Basin itself. Over an 8-year span starting in 1996, an 18-mile-long strip rose nearly 5 inches, only to dip back down by almost 3 inches in the subsequent 8 years. Then, out of nowhere, it surged up again at an unprecedented pace of almost 6 inches a year. A powerful 4.9 magnitude earthquake shook the basin in March 2014, stalling this relentless uplift. Since then, the ground has oscillated between sinking and rising until 2019, when it finally began to descend. Yet today, the basin stands about 5 inches taller than it did in 2000. Can there be another factor contributing to the 320% increase? Indeed, the supervolcano beneath Yellowstone National Park is the hint. A supervolcano means super destruction. An eruption from the Yellowstone supervolcano would be unlike anything the world has ever witnessed. It poses the greatest natural threat to human existence on Earth, with only 20 known supervolcanoes worldwide. Despite having erupted only 3 times in the past 2.1 million years, the Yellowstone supervolcano scores an 8 out of 8 on the Volcanic Explosivity Index. The fourth eruption might be closer than we think. The most recent eruption, approximately 640,000 years ago, was massive. When it happens again, the explosion will release toxic gas that would decimate crops and disrupt electricity supplies as far as the Midwest. The United States would experience drastically cold temperatures as a poisonous cloud blocks the sun for years. It would be the greatest catastrophe since the dawn of civilization, according to the European Science Foundation. In 2018, cracks began to appear, literally. Grand Teton National Park in Wyoming closed down because of a massive crack posing a potential safety issue. Hidden Falls and Inspiration Point were closed, and park rangers conducted a risk assessment. According to a source at the U.S. Geological Survey, the rock face crack is a typical rockfall-related risk. The Yellowstone supervolcano, which last erupted hundreds of years ago, ejected 240 cubic miles of rock, ash, and volcanic dust into the sky, leaving a 34 by 50 mile depression in the ground. This supervolcano is a looming threat, capable of wiping out humanity, akin to the impact of asteroids, nuclear, or biological warfare. Although the likelihood of a supervolcano eruption is low, the potential consequences are staggering. The Federal Aviation Administration spends more than $7 billion annually on aviation safety, even though a supervolcano eruption would be far more catastrophic than any plane crash. Yet, we largely ignore the threat posed by supervolcanoes, exposing ourselves to dangers we cannot fully anticipate. Yellowstone has been a national park since 1872, but scientists didn't fully understand the volcano's size until the 1960s. It wasn't until the 1980s that they realized it was still active and posed a significant threat. Yellowstone's eruptions can be thousands of times more powerful than the 1980 Mount St. Helens explosion, covering the northern Rockies in several feet of ash. Geologists are keen to understand what exactly is happening beneath Yellowstone's hot springs and geysers. They want to know if and when Yellowstone will erupt again, and how severe it would be. A giant eruption would be a low-probability, high-consequence event, a classic black swan, with the potential to impact both society and the Earth dramatically. Although not completely ruled out, the occurrence of such an eruption is difficult to predict. Recent research has shed light on the hidden architecture of Yellowstone. A team of researchers simulated how lava rises from the Earth's mantle to form two sizable chambers of partially melted rock beneath the park's surface. These two magma chambers are stacked, with a layer of solid rock in between. The lava emerging from the mantle flows freely and contains little gas. When it cools and hardens upon striking the relatively cold crust, it creates the lower chamber. The upper magma chamber, located on top of the lower one, is filled with explosively thick, gas-rich magma, similar to a shaken soda can. This two-tiered, geochemically varied architecture might explain the eruption rates and patterns over millions of years. Geologists have measured the speed of seismic waves from mild earthquakes moving through the subsurface rock using sensors positioned throughout Yellowstone. These waves move more slowly through heated and partially melted rock, allowing scientists to create MRI-like images of the two magma chambers. The term supervolcano is not technical. Yellowstone is referred to as a caldera, a volcano that forms a large crater. These are mountain-eating occurrences, evident from the park's unusually flat central region, which fell into the large hole or was blasted away during past eruptions. The first major eruption in the Yellowstone region happened around 2.1 million years ago, with the most recent one occurring 63,000 years ago. With a 320% increase in risk, the fourth eruption might be imminent. However, predicting the exact amount of magma required to start a caldera-forming eruption is challenging. While minor eruptions producing lava flows are relatively frequent, the last occurred 70,000 years ago. Despite Yellowstone's hibernation, scientists are closely monitoring every tremor to forecast what might happen next. Other calderas in the United States, like the Long Valley caldera in California near Mammoth Mountain, also pose significant threats. The U.S. Geological Survey keeps a close watch on these volcanic areas. Although large eruptions are rare, minor yet disruptive and deadly eruptions are possible, contributing to the increased risk of a sudden eruption. California, for instance, has 7 volcanic areas with molten rock zones beneath the surface. A magnitude 6 or greater earthquake on the San Andreas Fault is as likely as a volcanic eruption. If Yellowstone's supervolcano were to erupt, it would release an insane amount of ash and sulfur into the atmosphere, potentially ruining crops and altering the climate. The 1815 Mount Tambora eruption caused agricultural failures, harsh weather, and a drop in global temperatures, demonstrating the devastating impact such eruptions can have. The magma beneath Yellowstone is a powerful heat source, creating beautiful yet lethal geothermal features across the park. Understanding why supervolcanoes are so deadly is crucial. A supervolcano with an eruption magnitude of 8 or higher on the Volcanic Explosivity Index, ejecting over 1,000 cubic kilometers of material, can annihilate species and permanently alter the environment. These eruptions occur when rising magma from the mantle is unable to pass through the crust, building up pressure until it violently erupts. This can happen at hotspots like Yellowstone or subduction zones like Toba. Large igneous provinces, associated with these eruptions, can cover vast areas with lava and ash. The Yellowstone hotspot has created the Island Park caldera, Henry's Fork caldera, and Yellowstone caldera over millions of years. The Huckleberry Ridge Tuff, formed by the Island Park caldera's supereruption 2.1 million years ago, was the largest, producing 2,500 times more ash than the 1980 Mount St. Helens eruption. The subsequent largest eruption created the Yellowstone caldera and Lava Creek Tuff. The Henry's Fork caldera's smaller Mesa Falls Tuff is the only clearly visible caldera from the Snake River Plain Yellowstone hotspot. In the event of another major eruption, Yellowstone's supervolcano would eject ash thousands of miles across the United States, causing widespread damage. Fortunately, such eruptions are rare, but the potential for smaller, disruptive eruptions remains. Supervolcanoes are an inexhaustible source of apocalyptic intrigue, drawing attention from researchers and the public alike. Recent studies, like the one published in Geochemistry, Geophysics, Geosystems in September 2014, have examined the potential visual characteristics of a Yellowstone supereruption. They found that the volcano could engulf the Midwest in 3 feet of hazardous volcanic ash, burying states like Wyoming, Montana, Idaho, and Colorado. Such an eruption would destroy vegetation, collapse roofs, and damage electrical devices. Beneath Yellowstone lies a 5-mile-deep pool of hot lava, fueled by a massive plume of molten rock. This heat source powers the park's famous geysers and hot springs, with the ground above regularly rising and falling as the magma chamber fills and cools. The remote probability of a disastrous supereruption is why Yellowstone garners so much attention. An eruption with a magnitude of 8 or higher, ejecting at least 240 cubic miles of material, would qualify as a supereruption, capable of burying Texas under 5 feet of ash. Geologists have discovered evidence of at least 47 supereruptions throughout Earth's history, with the most recent occurring 26,000 years ago at Lake Taupo in New Zealand. The enormous Toba eruption 74,000 years ago led to a severe global cold spell, potentially wiping out the population of that time. Although the Earth has typically experienced one supereruption every 100,000 years, predicting the exact timing of such events is challenging. A supereruption would initially trigger strong earthquake activity within the park, fracturing the rocks above the magma over weeks or months. If a supereruption occurred, spewing miles of ash and debris, it could last weeks or months, leading to a doomsday scenario. Lava flows would be restricted to a 40-kilometer circumference within the park, but the majority of the damage would come from volcanic ash, a mixture of shattered rock and glass, dispersed nationwide. Scientists have concluded that an eruption would produce an umbrella cloud spreading evenly in all directions, covering the northern Rockies in 3 feet of ash, obliterating parts of Wyoming, Idaho, Colorado, Montana, and Utah. The Midwest and both coastlines would experience several inches of ash, with the severity depending on the season and weather. Such an event would be catastrophic, with volcanic ash destroying buildings, harming people, plants, and animals, ruining farms, jamming roads, causing respiratory issues, obstructing sewer lines, and damaging electrical transformers. Air travel across North America would come to a halt. As scientists monitor Yellowstone's tremors, the big question remains: what will happen if Yellowstone begins to tremble tomorrow? While scientists can't predict the exact outcome, most agree it would be catastrophic. The volcano has risen at the fastest rate ever observed over the last decade, with the risk of a sudden eruption increasing by a staggering 320%. Yellowstone experiences between 1,000 and 3,000 earthquakes annually, most with magnitudes of 3 or less, making them undetectable but crucial for understanding the magma chamber's expansion. Recent increases in seismic activity suggest additional magma is entering the reservoir, raising the risk of an eruption. Following each eruption, Yellowstone's supervolcano collapses into itself, engulfing the surrounding terrain, including trees, mountains, and other features. If this happens now, a caldera-forming eruption would pose a huge natural hazard. The 50 by 70 kilometer Yellowstone caldera contains remnants of the last eruption in the Lava Creek Tuff region, where thick volcanic debris remains. While Yellowstone is currently dormant, scientists are vigilantly watching every seismic activity to forecast the next possible eruption. The force building beneath the park for thousands of years has been restrained, but Yellowstone's hibernation does not guarantee it will never awaken. The crucial question is when it will happen and how severe it will be. Let us know in the comments below what you think about the nerve-wracking 320% surge and the risk of a sudden eruption at Yellowstone. If you're hungry for more thrilling content, smash that subscribe button and gear up for an adventurous journey with us. See you in the next video.